Hello everybody, today we are starting our new booklet, Booklet 2, Compounds and Chemical Equations. So now we're going to get into some real chemistry. So the previous section was really kind of a building up of some basic skills and learning the elements and the names, and now we're going to get right into it, talking about chemistry, chemicals. So this first chart is actually a really important one. This is the division of matter and how we kind of define the different possibilities in matter. So we divide matter into two concepts, the pure substances and the mixtures. And pure substances are further divided into elements, which we've just finished talking about. So the elements on the left here, and chemical compounds on the right of that. And so chemical compounds are essentially those combinations of elements that we're all familiar with. Homogeneous mixtures and heterogeneous mixtures, these are things that we can separate with just mechanical action, but it's the chemicals that really make chemistry interesting. Alright, so these are all types of things that we need to learn today, but let's get into it. So compounds. Atoms have a tendency to combine and form new materials. Only approximately 100 different atoms combine to form millions of materials that are found on Earth. So that's the 100 different elements. In some ways, atoms behave like letters of the alphabet, in that the 26 letters combine to form a huge number of words in the English language. A bond is a kind of glue that holds atoms together to form particles of a new compound. There are two types of bonds that we're going to be concerned with, the ionic bond and the covalent bond. There are actually other types of bonds, but we are not going to be concerned with those. But if you do go on to chemistry later, that's what you might learn about. So some common compounds are water, carbon dioxide, you exhale it, I'm breathing it out right now, ammonia, a cleaning fluid. Compounds all have the definite proportions of the elements that go into them. So for example, water always has twice as many hydrogen atoms as oxygen atoms. Carbon dioxide always has one carbon atom for every 2 oxygen atoms. And ammonia always has 1 nitrogen atom for every 3 hydrogen atoms. Think about it this way, that these are the little characters, right? And if I go and I'm drawing a person, if I'm drawing a little stick figure or something here, you know right away that this is wrong. There's something missing from my stick figure. It is not a stick figure of a person unless you put the head on top. So that's the same deal here. It is not water if I draw this. That's not water. That's, HO. That's actually something that's a base. It's a very dangerous chemical. If I add the other H, or if I write it as H2O, then I have water. And so it really, really matters what you write for the chemical formula. You must write the chemical formulas properly, or else you're talking about completely different ideas, completely different chemicals. So the 3 compounds that use atoms of these elements are above. So we have water, which uses hydrogen and oxygen. We have carbon dioxide, which uses carbon and oxygen. And we have ammonia, which uses nitrogen and hydrogen. So all 3 of these use common elements, but they're used in very different ways, giving them very different properties. So let's look at the water. Here, the water has 2 hydrogen atoms, 1, 2, per 1 oxygen atom. That's the oxygen here. Oxygen, and these are hydrogen. The carbon dioxide has 2 oxygens per 1 carbon. And then ammonia has 3 hydrogens, 1, 2, 3, for the 1 nitrogen. And you can also see that written out in their formulas. Notice these little subscripts, right? These subscripts indicate how many of the element that came right before it. So H2 implies 2 hydrogens. The oxygen has no number after it, so that implies 1. Carbon dioxide. The carbon has no number after it, so that tells you that there's only 1 carbon, one of them. And then there are 2 oxygens because there's a 2 after it. 1, 2. So that's what those numbers mean. All right. So from that point, we're going to start to we want to talk about some of these chemicals. And to start talking about chemicals, we need to start talking about why they are stuck together at all. One of the ways that we can stick 2 atoms together is something called an ionic bond. We kind of discussed this at the end of a lesson last booklet. Ionic bonds result when electrons are transferred from metal atoms to non-metal atoms. So when a sodium atom and a chlorine atom come together, it can be thought of that the sodium gives the electron up to form positive and negative ions. So the metal atoms lose their electrons, forming positive ions, while the non-metal ions gain electrons to become negative ions. The ions are then held together by the action of opposite charges in an ionic bond. This is known as the electrostatic force. And it is the force between any two charged particles. Metal element plus non-metal element equals an ionic bond. Particularly metal ion plus non-metal ion. You don't even have to do the chemistry. Sometimes you can find solutions that have these elements, just these ions just floating around in them. So if you dissolve some salt in your water, what you get is a bunch of these sodium pluses and chlorine minuses floating around, and then they can form ionic bonds with each other or with other elements that have opposite charge. Binary ionic compounds are formed by the combination of a metal element and a non-metal element. When the bond formed between elements is an ionic bond, the type of compound is called an ionic compound. What about that, eh? Ionic bonds form ionic compounds. Ionic compounds are generally known as salts. So salt is just a general name for an ionic compound. A general or a common name for ionic compounds. So we do have table salt, which is a specific type of salt, but we also have lots of other salts. There are salts that are poisonous, there are salts that are not poisonous, there are salts that are useful, salts that are used for conduction, salts that are used for insulation, all sorts of properties of salt. It's a very common category of chemical. To form an ionic bond, when the positively charged ion comes near a negatively charged ion, they are attracted to each other and they form a bond called an ionic bond. An ionic bond will hold the two ions together to form a compound. This is one of the strongest interactions. One of the strongest forces in the universe is at work here. Positives and negatives attracted to each other. This is a very strong way of connecting two elements together. The formation of compounds often takes place vigorously when metals and nonmetals are placed together. If a sample of sodium metal is placed in a container of chlorine gas, an explosive reaction will take place, and the sodium combines with the chlorine to form sodium chloride. The Bohr model below provides that explanation. And so we can see the explanation here. Here we have sodium. Sodium has the one electron on the outside shell, and it fills in that gap that chlorine had from being full. And so the sodium becomes +1, and the chlorine becomes -1. The sodium ion and the chloride ions are attracted because the opposite charges. Remember that little square we did? Once they have that extra electron, they are negatively charged now and positively charged. So they are attracted to each other. The sticking together is called the ionic bond. Okay, so that's our brief intro into ionic compounds, ionic bonding. The next thing we're going to talk about is chemical formulas. We've done a little bit more work on ionic bonds. We can also imagine things like, what if you had magnesium, which has a 2+ charge, right? Well, if you mixed magnesium and chlorines together, each chlorine can only gain one electron, so they only have one negative charge. But magnesium has 2 positive charges, and the universe doesn't like things to not be equal. So the universe will drift towards a way to satisfy this positive 2 charge on the magnesium with those chlorines. And that's where we get magnesium chloride has 2 chlorine ions. It has to have 2 of them. And so this becomes magnesium chloride, and we'll figure out how to name that in the next lesson. And it's the formula, the way they combine is set. It's defined ahead of time because we know that the chlorines are -1, the magnesiums are +2. So this is where we're going to start to use that periodic table where we figured out all those charges. And we can think about how we can do this with any set of nonmetal and metal ions that we know of. So I can give you, say, beryllium. Beryllium is in the second column, so it's a +2 charge, and I can combine that with, I don't know, oxygen. So oxygen is in the 2- column. So when we think about beryllium and oxygen coming together, we think, well, look at that. Isn't that nice? The +2 and the -2 are sort of equal but opposite. So then beryllium oxide is just combining the two. Pluses and negatives have to add up and balance out. It's like a little bit of doing your taxes. You got a certain amount of charge in and a certain amount of charge out, and you got to make sure they're equal so that you don't overspend or you don't underpay your taxes, I guess. Okay, I think we'll talk about the compound lesson in the next one, as I'd like you to kind of review this, and it's a good little sort of introduction into this idea. So we're going to get into compounds, and then the next lesson will be on naming and writing those compounds. All right, thank you very much, and have a great day.